Find the standard deviation, sample standard deviation from the sample variance. Now you see there's a lovely looking formula there. 1 over n times the sum from I equals 1 to n of x sub I minus x bar squared. All right, and then we also have a variation of that for a frequency table, but the only difference is that you see some f's in there rather than the absence of f. All right, so what you have here is a list of x values. Each one of them has a position within the sequence. All right, so this is I equals 1, I equals 2, and so on. All right, so the I values just give you they call it the index. It's the position within the sequence. Oh, good question. So if you go to Unit 1 Descriptive Statistics and then click on, you could either go to blank unit notes or class notebooks. It doesn't make a difference. Either one will get you there. I'll go to class notebooks. Click on it. Click on it like 7 times. Okay, so that's a broken link. All right, so don't go to that one. Blank unit notes. Unit 1 exploring data. And then you see the whole thing. No problem. I'll have to fix that other link because that's an important one. All right, so I represents the index or the position within the sequence. All right, so when I say x sub I, that's saying each x value in the sequence. All right, so that's a pretty long-winded explanation of something that's pretty simple. All right, but if you kind of read this inside out based off order of operations, it's telling us to take from each one of those x values, take the mean and subtract it. All right, so that's telling us that we got to find the mean. All right, so I'm going to do this on Desmos. I'm going to make a table. And then I'll show you how to do it on TI. Much easier on the TI. So you're like, why are we doing it on Desmos? Just so you can learn how to do it table-wise. All right. I'll also show you how to do it on Google Sheets. So there's a lot going on here. All right, I'm going to leave the settings here as x sub 1 and y sub 1. It really doesn't matter, but I created a calculator. It's posted on Schoology. That calculator has some different notation for the tables, but it's all ready to rock and roll for you. All right, so I'm going to type in the values 2, 3, 6, 3, 8, and 0. All right, so we have all our values entered in. I want to find the mean, so I go to function, under stat, mean, type in x1, and it'll tell you what it is. For the sake of making something a little bit more user-friendly, maybe you tap on that little fraction icon to get your answer in fraction form. All right. Although I don't remember the mean being that, so I'm concerned that I typed something in incorrectly, and I did. I missed a 6 along the way, right? Yep. It's one of the benefits of having worked with the same data set for the last 20 years. That was the right, it was supposed to be clean. So 4 is the actual mean. So x bar, I'll make a little note. X bar is equal to 4. I'll make a column here just containing the number 4. All right, all the way down the line. All right, so I'll go back to my table and do that. Type in the number 4. Procedurally, this could kind of be a pain. I mean, I think you'll probably agree when you think about it. If you had 150 values, to even type it in would be annoying, but then to type in the number 4 150 times and then do what we're about to do 150 times, that would be a nightmare. All right, so we want to learn a tabular approach. And in this case, once you have the first 2 columns in, that's really all you have to do, because the next column is just going to be x1 values minus y1 values, it'll run those computations for you. It's also creating a scatter plot for you, but you don't really need that. All right. In fact, you could turn off the scatter plots by tapping on the icon. All right. My fat fingers is not or are not cooperating, so let me go. There we go. All right. So this is helping support the showing the work on an assessment. You know, the AP will never ask you to go through the process of finding the standard deviation by hand, but they may ask you for certain elements of the process. All right. They may say, what is the sum of x minus x bar or x sub I minus x bar squared? All right. So just one part of the formula. So it would kind of be in your best interest to know how to make a table solution so that you can answer that one little question. All right. So x minus x bar. So x sub I minus x bar. We also want to square those values. All right. So it's really up to you. Do you want to do it all in one shot, or do you want to do it, in separate columns? I'll do it in separate columns. So let me get rid of the parentheses actually. Oh, I was about to put parentheses back in. All right. So -2, -1, 2, -1, 2, 4, and -4. All right. Very easy to do in your head for this particular problem, but you can see how if the numbers are funkier, then it would be troublesome. All right. X minus x bar squared. So we're squaring each of these values in the table. That would just be this column squared. So you could put parentheses around. And raise it to the second power all in one shot. That's assuming that you didn't know that -2 squared is 4. And, it might sound like I'm being a wise ass here, but the number of people who screw up little things like that is astonishing. All right. I chalk it up to, like, in the moment of truth, you're taking a test, nerves are kind of running wild on you. And, out of the 100 times that you do that kind of problem, 99 times you do it right. The one time you do it wrong is in the middle of a test. All right. So the technology will help you, save you from yourself there. All right. So this summation technique is telling us to add up this column of information. All right. So I would just take the sum of all that. Now, in Desmos, it's kind of a pain if you're using a touchscreen like I am. If you're using a keyboard, it's not bad, because what you would do is you'd copy all this into a new command. So function, under stats, you'd select total, and then you would type in what we just typed in that last column again. All right. If you're doing a touchscreen, it's kind of hard to copy paste, but on a keyboard, you just highlight, copy, paste it in. So x1 minus y1 quantity squared will give you a 46, and so that's the total. All right. So that's the sum part of it, 46. Now the sample variance. Now the question said find the sample standard deviation, but I'm finding the sample variance because sample standard deviation is really just the square root of the sample variance. Once you find one, take the square root of it, you find the other. All right. So 1 over n minus 1, n is the number of values in the set. There are 7 values. So 1 over 7 times the summation part of it, we've already taken care of that. All right, that's the 46. So after all this, it's saying, all right, well, divide that answer by 7. All right, so what I'll do is I'll just tack in a 1 over 7 right into the front, and you get a decimal answer, which could be converted to fraction form. All right, it helps save you from yourself in terms of rounding, although it's very disappointing that the fraction form is just the problem again. All right, so since I need the standard deviation, I'm going to then take the square root of that, square root of 46 over 7. All right, So what I would have to do is pop a square root over this bad boy. The problem is when you do it this way on a touch screen, it's a pain because now I'd have to copy all this stuff in. But if you do it on a keyboard, you just highlight and copy all this other business here and then just paste it right in. All right, so I have to retype it, but undo. I could show you a little strategy here. If you're ever in a jam like that, you're doing it on your phone or something, and you can't easily copy paste, set it equal to some dummy variable. Let it equal like a. I don't think I've used a. So let a equal that, and then take the square root of a. All right. So about 2.563. It's another instance where I don't remember that being the answer, but you know, it is what it is. That could just be memory. Let's see. It looks like I typed in everything. There are 7 values, right? Yeah. So it should be good. So that would be our solution. Well, we're about to check it anyway on the TI calculator. So we'll be in pretty good shape there. All right. Now, if you wanted to make something more user-friendly, you could use other commands. But like I said, I've already taken the time to do this for you. So let me show you the one that I created. Like I said, it's up on Schoology. Measures of center and spread. All right, so input your raw data into the table for a single list of information. It'll spit out the mean and standard deviation. That's pretty easy. But also for a frequency distribution, I got all the commands in there set and ready to go. All right, so you have an entire Desmos at your disposal. Mm-hmm. So on the TI, let me walk you through that. So stat, edit. I hit the wrong thing. Clear out. I don't need my second list of information here. I'm going to type in the 2, the 3, the 6, and all that good stuff. Six, 8, and 0. All right. Now again, just like Desmos, there are built-in features that'll do this stuff for you. The problem is, if you need a table solution, you're gonna have to know the ins and the outs of the calculator. So let me show you the table solution, and I'll show you the quicker way. You actually already know the quicker way. The same way that you would find the mean, that's the way that you would figure out the standard deviation. It's the SX in that stack calc 1. All right. But let me show you the table approach. So the first thing you would do is get the mean in. Well, you'd have to compute the mean, but you want to type that into the second column, L2, for each entry in L1. All right. So what I do, because again, if there's 150 values, I don't want to have to type in the mean, especially if it's something more complicated than the number 4. I don't want to have to type that in 150 times. So what I'll do is I'll just write an equation here to give a result of 4 into the L2 column. So I need it to correspond with every single entry in L1. So what I'll do right on L2 is I'll hit enter. I'm going to type in 0 times L1. That guarantees that whatever comes next is going to correspond with an entry in L1, and the result will be put in L2. So all I would just type in here is plus 4. So what this command is going to do is it's going to take each entry in L1, multiply it by 0, and add 4 to it. So for every entry in L1, it will produce a result in L2. You got to do that right on the column heading because it's a rule for the entire column. All right, when you hit enter, gives you 4s all the way down. Now, for only 7 entries, it's not a big deal to type in the number 4 over and over. But again, we want to be thinking bigger picture. We want to be thinking about the case where there's 150 data points. All right. Everything else is going to be very similar to what we just did, except instead of x1 and y1, we're going to be working with L1 and L2, the column headings. So right on to L3, hit enter. It allows you to type in a command. L1, second one, minus second two. Enter, does all the subtraction for you. On L4, L1 minus L2 squared, yeah, that would work. Or I could just take my results from L3 and square it. All right. You got to hit that caret key for a power other than 2. Hit enter. It'll square it, but for whatever reason I put a cube. So a little review on how to get rid of information after you accidentally type in the wrong things like a dingus. So hit clear on the column heading and hit enter, or down, either way. Then hit enter on the column heading, L3 squared, or use the power of 2 icon or a key. Now I have all the correct entries, so I'm just double checking my work as I go. All right. Everything else after that is just computation. But again, I don't want to have to add these up myself. I want, again, thinking 150 values instead of 7. So I would quit out of here, second mode. I want to use the sum function. That's in second stat. All right. Whenever you're thinking that you want to do something to the information that you typed into a list, any kind of operation, odds are it's going to be in the list menu. All right, so second stat. Go to math. You'll see option 5 is sum. Now, if you ever have trouble finding something in the TI, go to the catalog. Everything's there. Second 0. All right, but if I type in second stat math 5 and then type in whatever, I already forgot, I think it was L4. So second 4. It'll take the sum, which is 46, then divide it by the number of entries, which we had was 7. I got my decimal, square root of the previous answer, second negative symbol, and I got my 2.563. All right. An advantage for the TI calculator over the Desmos calculator. I mean, again, I wrote the whole Desmos program for you, but the TI has the built-in functionality, so that's where the TI kind of wins the battle here. If we're looking at the next example that talks about a frequency table, stat, edit. Now, I have all this information stored in here. I don't want to have to clear out every single column individually. It's a pain. So what I'll do is I'll go into the memory menu, so second plus. You'll see an option 4, clear all lists. If you select that and hit enter, it'll say done. You go back into stat edit, it'll wipe out all the lists. All right. It's the kind of thing that if you remember to do that before you go into the stat editor, it's an advantage. It gives you a little bit more time. All right. It saves you some time, I mean. All right. But if you're already in the list and then you realize it, you're like, well, now I just, like I'm already here, I might as well just clear out the list manually. All right. So 1, 2, 3, 4, and 5. Now, I am going to show you a little trick here for putting in a sequence of values. But let me put in the second column real quick because that's not a sequence. All right. So 10, 3, 1, 8, 5. All right. Again, we want to keep our eye on the prize here. We're thinking about instances where there isn't just 5 entries that we have to put in. There's 150. All right. So what we can do is go onto the column heading and use the sequence function. All right. This is sequence from 1 to 5. All right. So on L1, I'm going to hit second. Well, I'll hit enter first. I'm going to hit second stat. You're going to select ops. All right, so second stat ops 5. That brings up a sequence. All right. If you have your calculator well, first off, if it's a TI calculator with the most updated software, you'll have a menu that looks like this. If you have it in the right mode, you see mine, I have T's that show up instead of X's, but it really doesn't matter. You use whatever letter you want. All right. In this class, bless you, it's not really going to matter if you're in degree mode or radian mode or anything like that. All right. But what we're going to type in is X. And it comes up as T because I'm in parametric mode for another class. All right. So X, your start value, which is 1, your end value is 5, and your step is the increments. So if you're going by whole number units, it would be 1. If you're going by half units, it would be 0.5, quarter units, 0.25. Hopefully you get the idea. All right. So the expression is really just the equation that you're using. All right. So in this case, what I'm saying, when I say the expression is T, or X in your case, I'm saying your rule is A sub n is equal to n. All right, or A sub x is equal to x, or A sub t is equal to t. It doesn't matter. Where the variable is whatever you designate. All right, and then we're saying n belongs to the set of integers from 1 to 5. All right. So that's a little bit of pre-calc, algebra 2 kind of business there. But if you recognize that, it'll pop in the numbers from 1 through 5 for you. All right. Again, if it's 150 values, you don't want to get bogged down typing in the numbers 1 through 150. You just save yourself a lot of time just by recognizing that. All right. So then, quit out of there. Stat, calc. 1. My list of x values is in L1. The corresponding frequencies are in L2. Go to calculate, and we're looking for SX. All right, SX is our standard deviation. All right, sample standard deviation is SX, approximately 1.642. All right, we go to 3 significant. Now, if I want the sample variance, we need to square the unrounded form of SX. All right, so I can do one of two things. All right, I can take the 1.64169,324, type it into my calculator as a separate expression, and then square it. So I could do that, 1.641, it's kind of a pain, 69. It also opens up the possibility that you're going to screw up, like transcribing the digits. But here I would get, and this I can round, right? So here I would get 2.695. The other option would be to find the standard deviation symbol under the variables menu. All right, SX you could find under variables, statistics. All right, so variables option 5. You'll see option 3. All right. So pull up that command. You see it actually reports the most recent computed value for standard deviation. So pull up that command and square it, and it'll take the unrounded form and square it for you. All right, so you get your 2.695 there. All right. So that's it for today in terms of content. The rest of the time you have for project work. So let me stop the recording and I'll